In a quiet laboratory in Tokyo's Minato district, an elderly woman named Tanaka-san reaches out her hand. A robotic arm, sleek and impossibly gentle, reaches back. It doesn't just grasp, it understands. The pressure, the intention, the vulnerability of aging fingers. This isn't science fiction. This is Thursday afternoon. While the world watched Detroit crumble and Silicon Valley chase software dreams, something extraordinary happened in Japan. A revolution, quiet as a tea ceremony, but seismic in its implications. Today, Japanese companies control 50% of the global robotics market. Not smartphones, not social media, robots. The physical intelligence that will define the next century of human civilization. This is the story of how a nation facing its darkest demographic crisis transformed vulnerability into dominance. How the philosophy of Kaizen, continuous improvement, merged with cutting-edge technology to create machines that don't just work alongside humans, but care for them. This is the story of how Tokyo's robot renaissance is rewriting the future of automation, manufacturing, and human dignity itself. Let's rewind. The 1950s and 60s, Detroit was the undisputed king of industrial automation. General Motors, Ford, Chrysler. These weren't just companies, they were empires built on assembly lines that Henry Ford pioneered. American manufacturing didn't just lead the world, it was the world. The moving assembly line, invented in Highland Park, Michigan in 1913, revolutionized production. America perfected mass manufacturing, and Detroit was its beating heart. In 1961, General Motors installed Unimate, the world's first industrial robot, in a New Jersey plant. Created by Americans George Devol and Joseph Engelberger, it was revolutionary, a programmable arm that could weld and handle die castings, doing work too dangerous for humans. America invented industrial robotics. Remember that, because what happened next is a masterclass in how dominance can slip away. Through the 1970s, American manufacturers grew comfortable. Why innovate when you're already on top? Union wages rose, management focused on quarterly profits, and investment in next-generation automation stalled. American industrial robots were capable but crude, powerful, fast, and dangerous. Safety cages separated them from human workers. The philosophy was simple: robots do their thing, humans do theirs, and never shall the two meet. Meanwhile, across the Pacific, Japan was watching, learning, and reimagining everything. Post-war Japan had rebuilt itself through obsessive focus on quality and efficiency. Companies like Toyota didn't just copy American methods, they transcended them. The Toyota production system, lean manufacturing, Kaizen culture, these weren't just business strategies, they were philosophies. When Japanese manufacturers looked at robotics, they asked different questions. American question: how can we make robots more powerful? Japanese question: how can we make robots more precise? American question: how fast can we produce? Japanese question: how perfect can we produce? American question: how do we replace workers? Japanese question: how do we enhance workers? By the 1980s, Japanese companies like Fanuc, Yaskawa, and Kawasaki Heavy Industries were producing robots with unprecedented precision. Not just strong, accurate, not just fast, reliable. The 1980s brought Japan's bubble economy, but also something more lasting: robotics supremacy. While Detroit struggled with foreign competition and outdated facilities, Japanese manufacturers were installing robots that could handle delicate electronics assembly, intricate welding, and microscopic precision tasks. And they developed a crucial insight: the future wasn't robots or humans. It was robots and humans working together. By the 1990s, the equation had flipped. Japanese robots were building Japanese cars that were more reliable, more efficient, and increasingly more desirable than American vehicles. Detroit was hemorrhaging market share and jobs. The city that invented the assembly line was being beaten by the robots it pioneered. Let's talk numbers because they're staggering. Japan controls approximately 50% of the global industrial robotics market, Think about that. One nation, with 1.6% of the global population, produces half the world's industrial robots. The Big Four. 4 Japanese companies dominate this landscape. Fanyu Corporation. The yellow robots. If you've seen an industrial robot, there's a 50% chance it was Fanuc yellow. They produce over 100,000 robots annually and pioneered the concept of lights-out manufacturing, factories that run 24/7 without humans present. Their robots literally build Tao themselves. Yaskawa Electric, creators of the Motoman series, specialists in arc welding, painting, material handling, and increasingly, collaborative robots. Over 500,000 Motoman robots operate worldwide. Kawasaki Heavy Industries, not just robots, but the entire ecosystem, from manufacturing to logistics to medical applications. Their precision engineering comes from decades of aerospace and shipbuilding expertise. The specialists, high-precision robots for automotive, electronics, and machine tool industries. When accuracy measured in microns matters, you call Nachi. What makes Japanese robots different? One word: precision. Japanese industrial robots routinely achieve positional accuracy of plus 0.02 millimeters. That's 20 micrometers, about 1/5 the width of a human hair. This precision enables applications impossible for American or European competitors. Consider automotive spot welding. A modern car body requires thousands of welds, each needing precise positioning, exact force, consistent quality. Japanese robots perform these operations millions of times with virtually zero error rates. Or electronics assembly, placing microscopic components on circuit boards, handling fragile materials, intricate soldering, tasks requiring not just precision but consistency over billions of repetitions. But precision is just part of the story. Japan pioneered collaborative robotics, cobots, that work safely alongside humans without safety cages. Traditional industrial robots are powerful and dangerous. Drop a wrench near one, and you don't retrieve the wrench. You retrieve your hand if you're lucky. Japanese engineers asked, what if robots could sense human presence? What if they could adjust force dynamically? What if they could learn from human demonstration? Companies like Fanuc and Yaskawa developed force sensors, vision systems, and AI algorithms that allow robots to work directly with humans. These cobots are force limited, they can't crush you; collision detecting, they stop instantly upon contact; easily programmable, often through physical guidance; contextually aware, they understand their environment. Japanese robotics dominance spans industries. Japanese robots assemble nearly every major car brand globally, not just Toyota and Honda, but BMW, Mercedes, Tesla. Every smartphone, laptop, and television you own involves Japanese robots in its production. From sushi-making robots to agricultural harvesting, Japan applies robotics where others see only manual labor. Warehouse automation, sorting systems, autonomous delivery. Japanese technology moves global commerce. Surgical assistance, pharmaceutical manufacturing, laboratory automation, precision where lives depend on it. This isn't just technological prowess, it's economic strategy. Japan's robotics industry generates over $20 billion annually in direct revenue, but its indirect economic impact is exponentially larger. Every Japanese robot deployed globally generates demand for maintenance, training, integration services, and replacement parts, all revenue flowing back to Japan. It's the razor and blades model applied to heavy industry. Meanwhile, American robotics companies, they exist, but as niche players. The United States imports the vast majority of its industrial robots. Detroit's automotive revival depends on Japanese and German robotics technology. The country that invented industrial robots now buys them from Tokyo. But here's where the story takes a profound turn. Because Japan's robotics revolution wasn't born from strength, it was born from fear. Japan faces a demographic crisis unprecedented in modern history. 29% of the population is over 65 years old, the highest proportion globally. The birth rate has plummeted to 1.3 children per woman, far below replacement level. Population declining by 500,000 people annually. By 2050, Japan's population will shrink from 125 million to approximately 100 million. The working-age population is collapsing even faster. This isn't just statistics, it's an existential crisis. Who will work? Who will care for the elderly? Who will maintain economic productivity? Japan needs approximately 2.5 million elder care workers. It has fewer than 2 million, and that number is shrinking as caregivers themselves age out of the workforce. Elder care is physically demanding, emotionally draining, and poorly compensated. Burnout rates are astronomical. Facilities struggle to maintain adequate staffing. Most developed nations face versions of this crisis, but Japan, aging fastest and accepting minimal immigration, confronts it most acutely. And here's where Japanese innovation meets Japanese necessity. If necessity is the mother of invention, then demographic catastrophe is the mother of revolutionary robotics. Japanese companies began asking, can robots care for people? Not just lift packages or weld steel, but provide companionship, monitor health, assist with mobility, and preserve human dignity. The answer is transforming elder care globally. Developed by AIST, National Institute of Advanced Industrial Science and Technology, PARO, is a robotic baby seal designed for therapeutic interaction. It sounds absurd until you understand the science. PARO responds to touch, learns names, shows emotion, and provides companionship to dementia patients. Clinical studies show it reduces stress, improves socialization, and decreases medication needs. Over 5,000 PAR-0 robots operate in elder care facilities worldwide. Medicare even covers its use in the United States. Developed by Riken and Sumitomo Riko, Robiar is a nursing robot designed to lift and transfer patients safely. Its bear-like appearance is intentionally non-threatening. Patient transfer is physically demanding and injury-prone for caregivers. Robear can lift 80 kilos with precise control, reducing caregiver injury while improving patient safety and dignity. Created by Cyberdyne, yes, seriously, they kept the Terminator name, HAL is a powered exoskeleton that detects bioelectric signals from the wearer's muscles. For stroke victims, HAL assists rehabilitation. For elderly individuals, it enables continued mobility. For caregivers, it prevents injury during patient assistance. HAL is approved as a medical device in Japan and Europe, representing a fusion of robotics, neuroscience, and assistive technology. SoftBank's Pepper isn't designed for physical assistance. It provides emotional engagement. It recognizes faces, interprets emotions, holds conversations, and provides companionship. Deployed in hospitals, elder care facilities, retail environments, and schools, Pepper represents Japan's belief that robots can serve social, not just functional, roles. Here's what's revolutionary. Japan isn't using robots to replace human caregivers. It's using robots to enhance them. Robots handle physically demanding tasks, lifting, monitoring repetitive care routines. This frees human caregivers for what humans do best: emotional connection, complex decision-making, genuine empathy. Western culture, shaped by Frankenstein and Terminator, fears robots. Japanese culture, influenced by Astro Boy and Doraemon, embraces them. Shinto beliefs hold that all things, including machines, can possess spiritual essence, kami. Robots aren't seen as threats, but as helpers, partners, even companions. This cultural difference translates into technological advantage. While Western societies debate robot ethics theoretically, Japan deploys robots practically. The innovations developed for elder care are radiating outward. Disaster response. After Fukushima, Japanese robots entered radiation zones too dangerous for humans, performing reconnaissance and cleanup. Infrastructure. Aging bridges, tunnels, and buildings need inspection. Japanese robots crawl through sewers, scale towers, and assess structural integrity. Agriculture. With farming populations aging catastrophically, Japanese robots harvest crops, monitor soil health, and even tend livestock. Japan transformed the demographic crisis into technological advantage. The same challenges facing Japan, aging populations, labor shortages, rising care costs, will soon face China, South Korea, Europe, and even the United States. And when they do, they'll be buying Japanese robots. Let's return to Detroit because its story illuminates what went wrong and what lessons remain unlearned. Detroit's population peaked at 1.8 million in 1950. Today, it's barely 640,000. The city filed for bankruptcy in 2013, the largest municipal bankruptcy in American history. What happened? The simple answer: foreign competition, particularly from Japan. But that's incomplete. The real story is about adaptability, or its absence. In the 1970s and 80s, Japanese cars, Toyota, Honda, Nissan, entered American markets and shocked consumers. They were reliable. They rarely broke down. They lasted. American cars, by comparison, were famously unreliable. Detroit's quality control was lax, design was stagnant, and customer satisfaction plummeted. Why the gap? Automation philosophy. American manufacturers used robots for speed and cost reduction. Japanese manufacturers used robots for quality and precision. The former produces more units, the latter produces better units. In competitive markets, better wins. Here's the cruel irony. Detroit's decline accelerated because of and despite automation. American companies automated aggressively to cut labor costs, which created unemployment and destroyed communities. But they automated poorly, maintaining old designs and processes while simply replacing workers with robots. Japanese companies automated intelligently, maintaining skilled workforces while using robots to enhance quality, flexibility, and efficiency. Robots didn't replace workers, they elevated them. Detroit's workforce was trained for 20th century manufacturing, repetitive, manual, low skill. When robotics transformed production, that workforce became obsolete. Japan invested heavily in workforce retraining. Automotive workers weren't discarded. They were retrained as robot operators, programmers, and technicians. Manufacturing remained high wage because it became high skill. America, by contrast, lets workers bear the cost of automation. Factories closed, jobs vanished, communities collapsed. Detroit became a symbol of industrial decline. To be fair, America isn't entirely absent from advanced manufacturing. Tesla's gigafactories use extensive automation. Boeing employs sophisticated robotics. Medical device manufacturers lead in precision automation. But these are exceptions, and even they rely heavily on foreign robotics technology, primarily Japanese and German. American robotics companies exist. Boston Dynamics, now owned by Hyundai. Rethink Robotics, defunct. Universal Robots, Danish, and various startups. But none command market share comparable to Japan's Big Four. There's a new player in robotics, China. Massive state investment, enormous domestic market, and aggressive acquisition of foreign technology are building Chinese robotics capabilities rapidly. China is now the world's largest installer of industrial robots, though most are still imported from Japan and Europe. Chinese companies are closing the gap in manufacturing quality, and government subsidies make competition fierce. But here's the key. China is replicating the Japanese model, not the American one. Emphasis on precision, quality, and continuous improvement. Investment in workforce skills. Integration of robots with human workers. Detroit's decline teaches that automation alone doesn't ensure competitiveness. How you automate, why you automate, and what you do with displaced workers matters enormously. Japan automated to enhance quality and empower workers. America automated to cut costs and maximize short-term profits. 60 years later, Japanese manufacturing thrives while Detroit crumbles. The question isn't whether to automate. That ship sailed in 1961. The question is whether to automate wisely or foolishly, with foresight or short-sightedness, with social conscience or pure profit motive. Detroit chose poorly. Tokyo chose wisely. The results are visible from space. So Japan won the industrial robotics revolution. But that revolution is over. The next one is already here, and the rules are changing. Traditional industrial robots are programmable, but not intelligent. They repeat tasks with precision, but can't adapt, learn, or handle variation. Artificial intelligence changes everything. Modern robots integrate machine learning, computer vision, and neural networks. They can recognize objects they've never encountered, adapt to environmental variation, learn from demonstration, optimize their own performance, collaborate with other robots and humans dynamically. Japanese companies are aggressively pursuing AI integration, robots that learn industrial tasks through trial and error, improving performance autonomously. A Japanese AI startup partnering with Toyota, Fanuc, and others to develop industrial AI. Massive investments in AI and robotics startups globally, bringing technology back to Japan. But here's where Japan faces new challenges. In artificial intelligence research and development, America dominates. Google, OpenAI, Microsoft, Meta. These companies lead in AI foundation models, research publications, and talent concentration. China is second, with enormous government investment and leading companies like Baidu, Alibaba, and Tencent. Japan is third tier in AI, despite being first tier in robotics. This creates vulnerability. If AI becomes the brain and robots the body, Japan makes the best bodies, but imports the brains. Japanese companies recognize this threat and are investing heavily, but they're playing catch-up in AI, the way America plays catch-up in industrial robotics. The next frontier is humanoid robots, machines with human-like form and capabilities. Why humanoid? Because our world is designed for human bodies. Stairs, doorknobs, tools, all assume human shape. A humanoid robot can navigate human spaces without envy. Environmental redesign. Tesla's Optimus. Elon Musk's ambitious humanoid project, promising general-purpose robots for manufacturing, logistics, and eventually household tasks. Boston Dynamics Atlas, the most advanced humanoid physically, backflips, parkour, dynamic manipulation, but still primarily a research platform. Japanese humanoids. Japan has decades of humanoid experience. Honda's Asimo, Kawata's HRP series, SoftBank's Pepper, but these have been demonstrations more than practical deployments. The humanoid race is intensely competitive. America brings AI sophistication and Silicon Valley capital. China brings manufacturing scale and state backing. Japan brings precision engineering and robotics expertise. Who wins depends on which matters most: artificial intelligence, manufacturing capability, or mechanical precision. The ultimate prize isn't factory floors, it's homes. A robot that cooks, cleans, provides elder care, assists with disabilities, and handles household tasks would be a trillion-dollar market. Japan needs this more than anywhere else. Its demographic crisis makes home robots not a luxury, but a necessity. Current capabilities fall far short. Robots can vacuum floors, Roomba, Japanese brands, but struggle with laundry, cooking, and complex cleaning. Manipulation of varied objects in unstructured environments remains extremely difficult. But progress accelerates. Soft robotics, flexible, compliant materials enable safer human interaction. Advanced vision systems understand 3D space. Large language models give robots natural language understanding. Within 20 years, capable home robots are likely. Within 30, they may be common. And when that happens, who leads? The nation with the best robotics, best AI, and most urgent need. Japan checks 2 of 3 boxes, America checks 1, China checks 1.5. The future of robotics extends far beyond factories. Healthcare, surgical robots achieving precision impossible for human hands. Japan's Medicoroid is pioneering AI-assisted surgery. Services, restaurants, hotels, retail. Japan already deploys service robots widely due to labor shortages. Space and ocean, extreme environments where humans struggle. Japan's space agency JAXA and underwater robots explore where humans can't survive. Education. Robot teachers and tutors providing personalized learning. Japan's schools pilot these extensively. The real revolution isn't robots doing human tasks. It's robots and humans collaborating seamlessly. This requires intuitive interfaces, natural language gesture demonstration, safety guarantees, physical and cybersecurity. Economic models, how to share productivity gains, social acceptance, overcoming fear and stigma, ethical frameworks, robot rights, accountability, bias. Japan's cultural acceptance gives it an advantage here, but technological challenges remain universal. The robotics revolution is only beginning. Industrial robots were Chapter 1. AI-powered, humanoid, collaborative robots are Chapter 2. And the question is, will Japan maintain dominance, or will new players, America with its AI, China with its scale, overtake Tokyo's lead? So what have we learned? Japan's control of 50% of global industrial robotics isn't hype, it's reality. Walk into any modern factory from Michigan to Munich to Mumbai, and you'll find Japanese robots. This dominance stems from decades of obsessive precision engineering, cultural emphasis on quality and continuous improvement, strategic investment in automation technologies, demographic necessity driving innovation, pragmatic collaboration between government, industry, and academia. America invented industrial robotics, but lost the industry through complacency, short-term thinking, and failure to invest in manufacturing excellence. Detroit's decline symbolizes this failure. The city that pioneered mass production became a casualty of its own obsolescence. But America hasn't surrendered. Silicon Valley's software expertise, AI dominance, and venture capital ecosystem keep America competitive in next-generation robotics. The question is whether software superiority can overcome hardware deficiency. Can American AI compensate for Japanese mechanical excellence? Japan's robotics revolution teaches that automation's purpose matters. Robots deployed to cut costs and maximize profits destroy communities. Robots deployed to enhance human capability, preserve dignity, and solve social problems create value for everyone. Elder care robotics exemplifies this. Japan faced a crisis and responded with technology that helps rather than harms, that supplements rather than supplants, that cares rather than merely computes. As global populations age, every developed nation will face Japan's challenges, and they'll turn to Japanese solutions. Western fear of robots versus Japanese embrace matters practically. Cultural acceptance determines deployment speed, public investment, and innovation pace. Japan's Shinto-influenced view that machines possess spirit, kami, sounds mystical but produces concrete advantages. If you see robots as partners rather than threats, you develop better robots. Japan's robotics dominance affects everyone. Global supply chains depend on Japanese precision robots. Any disruption ripples worldwide. Automation drives productivity gains and labor displacement. How societies handle this determines prosperity or unrest. Robotics capability is a strategic advantage. Nations dependent on foreign robots face vulnerability. As robots become more capable and autonomous, questions of accountability, rights, and control intensify. We can't ignore China's rise. State-directed investment, enormous market, and strategic focus make China formidable. China wants robotics independence and global market share. It's systematically acquiring technology, training the workforce, and subsidizing domestic industry. Within a decade, China may challenge Japan's dominance. This has implications for global supply chains, technological standards, and geopolitical balance. Japan's lead isn't permanent. Maintaining dominance requires continuous innovation. AI integration, closing the gap with American and Chinese AI capabilities. Humanoid development, translating decades of research into practical deployments, new applications, expanding from manufacturing into services, healthcare, and homes. Global partnerships, collaborating internationally while protecting core IP. Complacency killed Detroit's dominance. Japan must avoid the same fate. There are glimmers of hope in Detroit. The city is rebuilding, attracting tech startups, leveraging university partnerships. American manufacturing is reshoring, partly due to pandemic supply chain disruptions. But Detroit's revival depends heavily on robotics, predominantly Japanese. The Renaissance Center overlooks factories filled with Fanuc yellow and Yaskawa blue robots. Detroit can rebuild, but it's building on Tokyo's foundation. The story of Tokyo's robot renaissance and Detroit's decline is ultimately about choice. Japan chose to confront the demographic crisis with technological innovation, to use automation as a tool for enhancing human dignity rather than merely cutting costs, to invest in precision and quality rather than speed and profit. America chose short-term returns over long-term competitiveness, cost-cutting over capability building, financial engineering over actual engineering. The results speak for themselves, but history isn't finished. The next chapter, AI-powered humanoid general-purpose robots, is being written now. The winners aren't predetermined. Will Tokyo maintain supremacy? Will Silicon Valley leverage AI advantage? Will Beijing mobilize its resources to dominance? Or will some unexpected player, India, Europe, even a Detroit reborn, surprise us all? One thing is certain, the future will be built by robots. The only question is whose robots, and what values those robots embody. Tokyo's samurai circuits carry the philosophy of Kaizen, continuous improvement, respect for craft, and care for human well-being. That philosophy, as much as the technology itself, is Japan's enduring legacy to the robot age. Thank you for reading. If you found this exploration valuable, please like, subscribe, and share. Leave your thoughts below. What role do you think robots should play in our future? Until next time, keep questioning, keep learning, and keep building the future we want to inhabit.